Okay, HVAC students and aspiring technicians. Today, I'm going to show you how to test a hermetically sealed compressor. So we need to determine which winding is the start winding and which winding is the run winding. And from the last video or from my other video, you can look and see the video says how to find the common run and start terminal on the compressor. In that video, I share with you also how to find the start winding, because the start terminal is on the start winding. But so assuming we know which is the start winding, then we can determine if the start winding is open. And assuming we know which winding is the run winding, we can determine if the run winding is open. So let's get to it. Set our meter to ohms, and then we check between the start winding and the start winding. From my previous video, we look here and we see on this compressor the start winding is here, right? Between the bottom terminal, there's this one here, and across here. And that is the highest resistance of the two winding. So when we check between the start winding, that's 7.4. We 7.4, and so therefore that winding is intact. There's no broken part in that winding. 7.4, and when we look up here, we got 7.4 across here. Okay, so that tells us that the start winding can be likely okay, meaning that it is not 100% concluded that this motor winding is good as yet. What we're checking is only between the winding itself, so we need to check to see if the winding is grounded. But so far we know for sure that the winding is not open. We know for sure the winding is not open, and the resistance may be okay. Now, to confirm that, in terms of the resistance wise, let's compare the start winding resistance to the run winding resistance. And what we got there, we got something, let me get this done good. We got something like 4.8. So 4.8, let's go back to this here, and this is what we checked in our previous video, the run winding, 4.8. So with the 4.8, now compare to the 7.4 that we got, we can safely say that the start winding is likely okay. It's not open. Okay, the winding is not open. And is the winding shorted? No, the winding is not shorted. If the winding was shorted, then the resistance would be lower. So that in one shot we can do, that is a shorted winding. The winding is not shorted. A shorted winding will be zero or close to zero, or somewhere below the specified resistance. And when we compare both resistance, we're seeing that the resistance look pretty much okay. But now we'll check the motor windings for a grounded windings. So, or the windings is grounded to frame. This is the frame. So this is the ground terminal right here. So a simple check to do, again, put it on resistance, not continuity, put it on resistance. So we go from the terminal here, from one of the terminals here, any terminal, all terminals you need to check, and we go to the ground. Make sure that you have a good grounded connection. Now sometimes you may have to scrape some paint off of the body and check it directly on the body. But this ground here looks very good to me. What you got? It's saying OL, which is infinite ohms. OL means over the limit. So that means it can read it's very high resistance. So right now we're at infinite ohms. Let's check the other terminal, which is the run terminal. Put it right like that, like so. And what we got there, OL again, infinite ohms. Let's check the start terminal. Make sure that you're making good contact. Always check several times what you got there. OL again. So therefore we can safely say this compressor is not electrically grounded. So let's recap. We check for an open winding, open start winding, open run winding. When we check between the terminal, the common terminal On the start terminal, the resistance was 7.4, which tells us that the winding is not open. Then we compare that 7.4 to the next winding, which is the run winding. We check between the common terminal and the run terminal, and the number was 4.8 ohms. So when we compare the two, we can safely say that the start winding, it is good in terms of resistance wise, or likely to be good in terms of resistance wise. Then we check between the terminals or the pins of the compressor to the ground or the frame of the body. But be careful, this is not the body of the refrigerator itself or the unit itself, but this is the frame of it or the body of the compressor itself. So we need to scrape some paint off of the compressor and make very good contact. But with this pin leads here, I go straight into the ground screw here, straight into the ground screw, and I just scrape it and I work it down a little, and I made good contact. Now, how do you know I'm making good contact? Look at this here. So if you go here, the meter should move. See that? The meter move. Therefore, I'm making good contact in this. I raise it, pick it up. Oh well. So this is another way that you can check that you're making good contact. Your leads or your hand is pressing hard enough, or you're making proper contact electrically. So we go from here, from the ground screw here, that's the body of the compressor, to all the terminals one at a time. If any one of the terminals you pick up any resistance, this meter move just a little bit, anything that show up on that meter, that compressor is electrically grounded. But for this, in this case, in this scenario here, the compressor is not electrically grounded. So that is how you check for an open winding. A shorted winding, it is not shorted. If the winding was shorted too, then the start winding would not read 7.4. It will be very close to the run winding. That's partial short, or a totally shorted compressor will be either 0 or close to 0. That's a totally shorted compressor windings. Okay, so that is how you check for open winding, a shorted, a partial short, and short to ground compressor winding. Okay, aspiring students and HVAC technicians, see you on the next video.